Good day. Welcome to our YouTube channel. So if you're new here, my name is Stifler and I'm the one who's going to be helping you with this content, this educational content. So if you're new, please just help us by subscribing to this channel and also liking and sharing with your mates. I'm not going to leave you stranded. I'm going to help you with all the content, mostly on mathematics and physical sciences. So if you have been on this channel for a long time, welcome back. So today I'm going to be dealing with alcohols, right? So I'm going to teach you how to draw and also name these alcohols like we did on previous lessons. So today we're on lesson 5. So let's just get straight right. So alcohols, what are alcohols? So alcohols, this is a homologous series. This is a homologous series of hydrocarbons. So this is a homologous series of hydrocarbons that are having a hydroxyl group. They're having the hydroxyl group. So the functional group of this is a hydroxyl group, which is identified by this O and H. So this O is having single bond. You remember on ketones and aldehydes, there was a double bond between carbon and oxygen, but now it's a single bond, and also this oxygen is also having a hydrogen attached to it. So this is the functional group of this, right? And the general formula of this, the general formula of this is just CN H2N plus 1, and then we also include the OH like that. So that is the general formula of these alcohols, right? So we are going to talk about how to name this and also how to differentiate between primary, secondary and tertiary alcohols, right? So let's get straight to naming alcohols. So there is nothing new in naming these hydrocarbons. We still adopt some of the rules that we're using on the previous chapters, right? So if you haven't watched our previous chapters, you can go into this playlist and you can watch the videos that are in these chapters that are naming some of the previous hydrocarbons, right? So the first step, like always, we identify the longest continuous carbon chain. So that is the parent chain, and it also must include this hydroxyl group. So the longest chain must include this hydroxyl group. From then, you write the name of the longest chain as if you are writing the alkane, but now you replace the E in the alkane. So now you are replacing the E with the ol. Just for an example, if you're having 3 carbon atoms, we know that in alkanes we're supposed to write propane, right? But now we are replacing this E with the O and L, and then it becomes propanol, like that. So if you're having 3 carbon atoms in the longest chain or more, right? Now we are supposed to number the carbon atoms. Now we are supposed to number the carbon atoms from the side that is closest to the functional group, which is the OH, right? We number the carbon atoms from the side that is closest to the functional group. And still we indicate the number where the functional group is at, just like we're doing in the previous topics, right? We just number the carbon atoms and indicate where the functional group is at. And always remember as well, the functional group is more prioritized than the branch. So if we are having the branch at another end and the functional group at another end, we start with the side that is closest to the functional group more than the branch, right? So let's get some examples on how to name these alcohols, and then from then we can talk about the primary, the secondary, and the tertiary alcohols. So let's see how we can do this, right? So on the first one, we can see our longest chain there. It has 4 carbons. So it's supposed to be a butane, right? And then from then, our hydroxyl group is coming close to this end. So we number from this end. So it will be 2, 3, 4. So it's coming on carbon number 2. So it means that on carbon number 2, we are having the all. This all represents that this is a alcohol. So this is the hydroxyl. This is representing the hydroxyl. So putting the name together now, we start with the parent name. So this will be butane 2 all, just like that. As simple as that. Is not difficult. So when you go to the number 2, let's try to work out number 2. So if you want to try this before I can continue, you can pause the video and work on it, and I'll resume in 3, 2, 1. So on this, let's check as well. So the parent chain, or the longest chain, is carrying 5 carbons. Can you see that? It is carrying 5 carbons. So it's supposed to be a pentane, right? So let's see. So we can see that from this end, we are having a branch that is coming on carbon number 2. And also from that end, we are having the alcohol coming on carbon number 2. So as I said, we prioritize the alcohol more than the branch. So it means that we are going to number from this side. So 1, 2, 3, 4, 5. So it means that on carbon number 4, we are having a methyl, and on carbon number 2, we are having the all, right? So just like in the previous, we first naming the branch, and then comes the parent chain and the functional group, right? So it means that this name is going to be on carbon number 4, we are having a methyl, right? And the parent name, which is pentane, and this is coming on carbon number 2, so that will be 2 all, just like that. Just like that, as simple as that. So that is the name of this, right? And lastly, on that one, so this one becomes simple. As I explained in the previous, where there were the rules, I said if there are 2 carbons or less, there is no need to number your carbon atoms. So here we are not going to number the carbon atoms. So it means that this is just coming on the first one, right? So we name this as if we are naming the alkane. So 2 means that it's ethane, right? And we're having the alcohol there. So this just becomes ethanol. There's no need to number the carbons. We start numbering the carbons when we're having 3 or more carbons in this chain. I hope you got this right and we are able to name, right? So now let's go to classification of these alcohols, either is primary, secondary, or tertiary alcohol. So now how do we differentiate between primary, secondary, and tertiary alcohols? So to differentiate this, we differentiate the carbon that is carrying the hydroxyl. So the carbon that is carrying the hydroxyl is the one that matters in differentiating between these three. So in primary, the carbon that is carrying the hydroxyl is always at the end of the chain. It's always at the end of the chain. So it means that this carbon is only bonded to one other carbon like this. So if we're having something like this, so this carbon here is only bonded to one other carbon. Can you see that? So this carbon that is carrying the hydroxyl is only bonded to one other carbon. Just like an example, if we can have something like so this carbon here that is carrying this hydroxyl is only bonded to one other carbon. Can you see that? So this carbon here that is carrying the hydroxyl is only bonded to one other carbon. So it means that that's a primary alcohol. If you have the hydroxyl carrying carbon at the end of the chain, then it means that that's a primary alcohol. And when you move to the secondary now, it means that the secondary alcohol, this carbon that is carrying the hydroxyl, it's bonded to two other carbons. Can you see that? So this is bonded to two other carbons like that. So it's more like it's in between the continuous chain. Can you see that? So just for an example, if we're having a secondary alcohol, we are having something like this. So this carbon that is carrying this hydroxyl is just bonded to two other carbons like that. So it's bonded to just two other carbons. Can you see this carbon that is carrying this hydroxyl? So this carbon is just bonded to this carbon and that carbon like that. So it is bonded to two carbons, and here it is bonded to one carbon. So we are talking about the carbon that is carrying the what? The hydroxyl group. And lastly, if we are talking about the tertiary alcohol, so the tertiary alcohol, this carbon that is carrying this hydroxyl, it is bonded to three other carbons. So if you can see, this carbon that is carrying this hydroxyl, it is bonded to three other carbons. So it means that this carbon, and that carbon. It's more like where there is this hydroxyl, there is also a branch on that. So to draw an example, we can have something like this. We can have something like this. So it means that this is a tertiary alcohol now, because this carbon that is carrying the hydroxyl, it is bonded to three other carbons. So 1, 2, and 3. The carbon carrying the hydroxyl, it is bonded to three other carbons, 1, 2, and 3 like that. Can you see that? So that's how you can differentiate between primary, secondary, and tertiary. You just focus on the carbon that is carrying the hydroxyl. So the carbon that is carrying the hydroxyl is the one that you focus on. If it's at the end of the chain and it's only bonded to one other carbon, then that's a primary alcohol. If it is bonded to two other carbons and it's in the middle of the chain, that's a secondary alcohol. And on the tertiary, the carbon that is carrying, it is bonded to three other carbons like that. I hope you got the difference between primary, secondary, and tertiary alcohol, right? I'll just draw some of the compounds here, and then we can name them and also tell if it is a primary, secondary, or tertiary alcohol. So let's see how we can name this and also identify if they are primary, secondary, or tertiary alcohols. So on this start, the first one, let's see. So the longest chain here, it is a butane, right? And our alcohol is closest to this side. So we're numbering from this side, 1, 2, 3, 4. So on carbon number 3, we're having a methyl group. And on carbon number 2, we're having the ol, right? So putting this together, we first name the branch. So the branch will be 3-methyl, and then the parent name, butane, and then on carbon number 2, we're having the ol. So let's identify this. So identifying this, we can see that this carbon that is carrying this is only bonded to 2 carbons. And we said if that's the situation, then this is a secondary alcohol. So this is a secondary alcohol. Moving to number 2 there, if you want to try this out, I'll pause this video, or you can pause this video and resume in 3, 2, 1. So on this number 2, to name this, so we first identify the longest chain, which is the butane, right? And then we number the carbon atoms from the side closest to this. So we're numbering 1, 2, 3, and 4. So on carbon number 3, we are having a methyl group. And on carbon number 1, we are having the ol, right? So to put this together now, it means that we can start with the branch. So this is 3-methyl, and then the parent name, butane, and then on carbon number 1, we're having the ol. So this is 3-methyl butane, 1 ol. So to identify if it is primary, secondary, or tertiary, we check the carbon that is carrying the alcohol. This carbon is only bonded to 1 carbon, so which makes this the primary alcohol. So this will be the primary alcohol. And moving on to the last one, again, if you want to try this, pause the video and resume in 3, 2, 1. So on this one, again, we are going to identify our longest chain. So this longest chain has 5 carbons. So this is supposed to be a pair 10, right? And we can number the carbon atoms from the side that is closest to this hydroxyl. So if we number from this side, that's 1, 2, 3. And from that side, that's also 1, 2, 3. So we can number from either side, because every side is just giving us the same number of the carbon that is carrying the what? The hydroxide. So now on carbon number 3, we can see that we're having a methyl group, and also on carbon number 3, we see that we're also having the ol, right? So putting this together now, it means that we're going to start with the branch. So this is 3-methyl, right? And then pentane, the parent name. And then on carbon number 3, we're having the ol, like that. So to tell if it is primary, secondary, or tertiary, let's look at the carbon that is carrying the hydroxyl. So this carbon is the one that is carrying this hydroxyl. So this is bonded to 1, 2, and 3 carbons. So if that situation happens, we call that a tertiary alcohol. So that's a tertiary alcohol. So I hope in this exercise you were able to differentiate clearly between the primary, secondary, and the tertiary. Just like I said, the carbon that is carrying the hydroxyl, it is also the carbon that is having a branch. Can you notice that? As simple as that. So I think there's still a bit of time, so we can go to the carboxylic acids and we can talk about the carboxylic acids. So I won't talk about the esters in this section. I'll just do the reactions of the esters as a chapter on its own. So carboxylic acids, I hope you still have the energy, right? If you don't have the energy, you can pause and watch this again at another time. So what are carboxylic acids? So these are this is a homologous series of organic compounds, right? So these organic compounds have the functional group. They have the functional group called the carboxyl. They have the functional group that is called the carboxyl functional group, which can be represented by this. So can you notice that this carbon is bonded to a double bond and also a single bond, or that is carrying also the H like that. So that is the functional group of hydroxylic acids and it's called the hydroxyl. And the general formula for this, it is just CnH2n plus 1, and we also represent this carbon that is carrying the carboxyl group. So naming these carboxylic acids is easy. It's also the same way as naming the aldehydes, right? Because this functional group is always at the end of the continuous chain. So this is always at the end of the continuous chain. So to name them, it becomes easier. So to name, we just identify the longest continuous chain. So we just identify the longest continuous chain. And after identifying this longest continuous chain, that is also carrying what? That is carrying the carboxyl. So that is carrying the carboxyl. And then from then, what do we do next? So the next step, it is to write the name of the longest chain. So now we write the name of the longest chain as if we were naming alkanes. So as if we're naming alkanes, but now we replace the E in the alkanes with this. Now we replace it with oic acid. We replace with oic acid at the end of the name. So oic acid is the name that can help you identify that this is a carboxylic acid. So let's take a bit of examples and you see how you can name this carboxylic acid. So this is a carboxylic acid, right? So let's check. So we identified the longest continuous chain. So this chain is having 1, 2, 3, 4, 5, including this that is carrying the what? The hydroxyl, right? So 5 carbons, if we are naming it, said we name as if we're naming the alkanes, right? But now we replace this E with what? Pentanoic acid. So now this becomes the pentanoic pentanoic acid. So oic and acid replaced the E, right? So this is pentanoic acid. So this has no much of problems when naming. So it means that if there's only one carbon in the chain, that's a methanoic acid. If there are two, that's ethanoic acid. 3, that's propanoic acid. 4, that's butanoic acid. 5, it is this. So 6, that's hexanoic acid. 7, heptanoic acid. And the 8th one will be what? Octanoic acid. So nothing is complicated there. It's just the way it is, like that. I hope you enjoyed this session with me. I really enjoyed. So I hope to see you coming back again to watch these videos. The next time we are meeting, I'll be talking about isomers. And that will be the end of the part 1 of organic chemistry. So the part 2, I'll be talking about the physical properties, right? So if you have really enjoyed, please show me by subscribing, liking and sharing this video with your mates. I will see you next time. I hope to see you next time. Thank you for watching.